Hello. Today we will study about Lussacs law of combining volumes. After we have completed our mole concept part, the problems on it, today we will study the theory and problems part of Gay-Lussacs law of combining volumes. So let us first go into it one by one. Let us first understand what is the Lussacs law one step by step, and then after that we will solve one or two problems that will make the concept clear. So what is the statement that has been given? The statement that has been given over here is when the gases react, they do so in volumes. As the law itself says, it is a law of combining volumes. So in the statement also, the thing has been represented when gases react. So there is some combination which has been already said in the heading, that is combining volumes. As this statement is also asked in examination, so we have to remember this statement very clearly. So the first phrase which is written over here is when gases react, they do so in combining volumes. So that is basically what is the heading. From there only we can write this. So this part you can remember easily. Which bear, remember one thing, this statement and this law is applicable only to gases. Which bears a simple whole number ratio. Okay. So the gases are reacting, they are doing so in volumes. Now these volumes which are reacting are bearing a simple whole number ratio to one another and to the volumes of products. That means when the gases will react, it will form some other gas. All these reactants and products both will have a simple whole number ratio between one another or amongst one another. That is it. If gaseous, so as I said, it is the law which is meant for gases only, provided the temperature and the pressure of the reacting gases and their product remains constant. Okay. Another important thing over here is in Gay-Lussacs law of combining volumes, the temperature of reacting gases and products has to be constant. We will come to it one by one as we go. The concepts regarding the statements will become more clear. So let us first take a reaction. In any problem, they will say either nitrogen reacts with hydrogen, or they may say that hydrogen will react with oxygen. They may say that a hydrocarbon is burnt in air. Generally, there are 2 or 3 kinds of reaction they asked in Gay-Lussacs law of combining volumes. So it is not very difficult to predict which question or which type of questions that can come. So first of all, we have taken here a reaction, that is nitrogen will react with hydrogen to form NH3. This process is called Haber's process. Very important. It is important in inorganic chemistry also. It is generally a reversible reaction. It is not a one directional reaction. It is a reversible reaction. So first step should be balancing the reaction. I hope you all know how to balance the reaction. Still I am giving you a little fact over here. That is, see here there is N2, there is 2 atoms of nitrogen, and here there is 1 atom of nitrogen. So first I put 2 over here. So it becomes the hydrogen amount in the product side becomes 6, and here there are only 2 atoms of hydrogen. So I put a 3 and make it 6, and I make it all even. So from here I can easily see 1 volume of nitrogen reacts with 3 volume of hydrogen to form 2 volumes of ammonia. So the ratio between them is 1:3:2. That is a simple whole number ratio. So this part is proved. Next, sorry, I'll again go down. Next, it has been stated in the problem in the statement of the law at same temperature and pressure. So, what is that part? We have to understand what is that part. Temperature is constant, let us take it C1. Pressure is constant, let us take C2. As we are talking about gases, let us write the gas law. PV by T is equal to constant. Everyone knows this. So let us put C1 in place of T and C2 in place of P. So it becomes C1 into V. Please solve it while I am giving this lecture. You please have a pen and paper in your hand and do this. Just put PV by T is equal to K. Okay, next line, in place of P put C1, this one, then in place of T put C2, this one, as both are constant in the Lussacs law, and V will be as it is. So if I take this part to this side, it becomes V is equal to K into C2 by C1. So let us assume that it is K dash. Okay, so what is happening now? Volume is becoming constant. Sorry. So as the volume became constant, that is why the volumes can bear a simple whole number ratio, because at same temperature and pressure, volumes now can be quantified. Otherwise, at differing temperature and pressure, it would be very difficult to predict that how much volume will react and how much volume will come as a product, because reactants are different, products are different. If temperatures and pressures also become different in reactants and products, then how would I predict that how much volume has been incurred into the reaction and how much volume will come as a product? It is only possible because the temperature and pressure is constant, which makes the volume constant. This volume constant does not mean that the reactants and the product, this one, sorry, doesn't mean reactant and products have same volume. It means that as the temperature and pressure remaining constant, if there is 1 mole of reactant or 1 volume of reactant is there at the outset of the reaction, afterwards if there is half volume actually left, I can easily quantify that half volume because the temperature and pressure has remained same. That is the reason, nothing else. Okay, now let us go to the first problem. After doing the problem, our concept will be much more clear. So see the problem over here. N2 reacts with H2 to form NH3. It is the same reaction that we have discussed above. Calculate the volume of NH3 formed if N2 reacted with 6 liters of H2. Okay, so first again we go to our first step, that is write the reaction. N2 plus, I already know the balanced equation now. So I write the volumes first, 1 volume, 3 volume, 2 volume. Okay, so next, what has been given? I'll write given H2 6 liters. What is asked to find? We do not know what is the amount of NH3 formed. So from the reaction I can say one volume, sorry, 3 volume of H2 forms 2 volume of NH3. So now it is said in the problem 6 liters. Anyhow, I can here from here I can write 3 liters of H2 forms 2 liters of NH3. I hope everybody will agree with me on this. Afterwards, I'll follow just unitary method and nothing else. 1 liter follows 2 by 3 liters of NH3. So how many liters of H2 actually we have given in the reaction? 6 liters. So 6 liters will have 2 by 3 into 6, just cancel out to 4 liters of NH3. So here 4 liters of NH3 is formed. That's it. So we will now go to the next problem. Next problem over here is C2H2 burns in air to form CO2 and H2O vapor. So this is a hydrocarbon. I first write the reaction. It burns. When a hydrocarbon burns, any burning that needs oxygen. So it is basically reacting with oxygen. We know that. What does it form? CO2 plus water vapor. Here I have not mentioned any STP. In this kind of problems, if nothing is given, you can write that we have assumed reaction is carried out at same temperature and pressure. Okay, first, what should be our first step? Our first step should be balancing the equation. Here there are 2 carbon, so I'll put here 2. Okay, let me put 2. And here there are 2 hydrogen. Already there are 2 hydrogen, but I have to make this even. So let me put 2 over here. And to balance the hydrogen over here, I'll put 2. Now there becomes it's 4 carbon, so I make it 4 carbon. So how many oxygen will be in the product side? Here 2 and here 8. So total 10. So I'll make it 5. Now it is balanced. 4 carbons, 4 carbons, 4 hydrogen, 4 hydrogen, and 10 oxygen on the both sides. So here let us go by the same thing. 2 volume, 5 volume, 4 volume, 2 volume. This is water vapor. Okay. Now, what is the question? Question is C2H2 burns in air to form CO2. They have asked you to calculate the volume of air. Please do not waste your time thinking on this. We can take care of it later. How much C2H2 has to be burnt? 50 centimeter cube. So I will first write 2 vol C2H2 requires 5 vol O2. 2 liters, or I'll go for 2 centimeter cube to balance the units. same unitary method, nothing else. Now the problem is quite same as the previous one. Now I have to find the volume of air. Okay, so air 20% oxygen. You know this? I know this. Okay. What does it mean? 100 centimeter cube of air has 20 centimeter cube of oxygen. Fine. So I can easily write. So what we have to find out? I have to find out air, not oxygen. So I'll write this line in a reverse way. "20 centimeter cube of oxygen is there in 100 centimeter cube of air." So how much oxygen was required over here? 125. But let us go for again a lengthier method. I like lengthier methods. It causes you less mistakes. So okay, I'll do it together. Sorry. Now I'll go for 50 centimeter cube. Oh, sorry, 125. Right. So basically, a lot of corrections. Centimeter cube of O2 is there in how much centimeter cube of air? That's what you have to find out. 100 by 20 into 125. So you cancel it out again. So it becomes